Welcome to the Oxygen Alliance YouTube channel, where we bring you videos on installation, maintenance, and various trainings on oxygen equipment and devices. If you have comments and or questions, drop them in the comment section below or write to us info@oxygenalliance.org. Remember to like our videos, subscribe to our channel, and hit the notification bell.
Hello everyone, welcome and thank you for joining us for today's Partners Talk brought to you by the Oxygen Alliance. My name is Janet Douglas and I'm a biomedical engineer for Oxygen Alliance. I'm hosting this call from Lilongwe, Malawi, and I would like to know where you're joining us by typing your name in the chat as well as your location. And if you also want to be on our emailing list to be able to get communications on the upcoming webinars and events, may you please type your email as well in the chat. So for today, we have brought to you the third webinar on medical imaging equipment series, as we'll be now diving into the magnetic resonance imaging, in short, MRI. So we're delighted to have our special guests from Philips, who are none other than Boniface Oragi and engineer Kennedy Job. So Boniface is the head of operations and customer service, as well as engineer Kennedy is the field service engineer. So this tour will take us through the planning for a new MRI, as well as the common issues and optimal handling practices in the cases where you have a magnetic resonance imaging equipment. So I would like to hear from you. So may you please stay with us, and I encourage you to take notes as we look forward to hearing your questions as well as your comments at the end of this presentation. I'd also like to remind everyone that we'll be issuing certificates at the end of this same topic to everyone who is going to attend 60% of the webinars on medical imaging equipment. And for that, we'll be pasting a link for a form at the end of the presentation for everyone to fill. So the more reason we're putting this form is for us to identify you when it comes to the time when we'll be issuing these certificates. So without wasting much of your time, may I now hand over to the first presenter on this webinar, on this call, who is none other than Boniface. Over to you, Boniface, and then you'll pass it over to Kennedy after you're done. Thank you.
Yeah, thank you very much, Janet. Really glad to be here. My name, as Janet mentioned, is Boniface Orangi. I lead the customer service and operations team for Philips in East Africa. So we cover the countries of East Africa around Kenya, Tanzania, Uganda, Burundi, Ethiopia, and a couple of other countries where we still don't have direct operations, but we operate through our partners. On the call, we also have my colleague, maybe Kennedy, you can introduce yourself.
Good evening, everyone. My name is Kennedy Njogu, field service engineer. I work with Philips East Africa, and I'm glad to join this webinar to share ideas with different professionals in the medical field in Kenya and also in East Africa. Thank you.
Yeah, thank you very much, Kennedy. So for this particular talk, we prepared the talk to be in 3 different sections. So first, Kennedy will take you through, how an MRI works, what an MRI is and how it works. Then I'll pick it up from there, and we'll go through how to actually procure and prepare your facility for the installation of an MRI system. And lastly, I'll also give it back again to Kennedy, who will talk about some of the common technical challenges that we face, especially as professionals in the engineering field when we are working on the MRIs, and especially for hospital biomeds who work with this equipment on a day-to-day basis. So yeah, just to kick us off, like I said, we'll be discussing how an MRI works, and our first slide will be on how it works. So Kennedy, go ahead, please.
Thank you, Boniface. So I've been privileged to work in the medical field for a number of years. Currently, I'm majoring in MRI. It has been an interesting journey. You start from the basics of how an MRI works up to the advanced level of troubleshooting, image quality of an MRI system. So the way an MRI works, first of all, you need about three components for you to get an MRI image. First of all, you need the magnetic field. The magnetic field can be either permanent magnet, or it can be a superconductor. So that is current flowing through superconductors. So currently, we don't have any permanent magnets. So I will explain how, using an example of a superconductor. So the MRI, you need the magnetic field, which can range from 0.3 Tesla, 1.5 Tesla to 3 Tesla. And then also you need the source of the signal. The source of the signal, we usually, in the medical field, it's the hydrogen molecule. So the hydrogen molecule, or we can say the hydrogen atom, it has a magnetic property whereby the atom, it precedes in a certain field. So when it interacts with the main magnetic field,
Kennedy, we lost
sorry
you.
about that. So I was explaining of how the field, the magnetic field, interacts with the hydrogen atom. So our human body has 70% water, and in the 70% water we have H2O. So the hydrogen has magnetic properties. So for you to get an MRI image, you need to excite the hydrogen atom for it to produce a electromagnetic wave. So the way you do that, you subject the hydrogen molecule or atom in a magnetic field, a strong magnetic field. So the hydrogen atom will align south to north. Then you need to disturb that alignment of the hydrogen atom from north to south. The way you disturb that alignment is by introducing an electromagnetic wave. So this is where now we have the RF amplifier. So the RF amplifier produces an electromagnetic field. So now we are talking, we have the electro and we have the magnetic. So the wave has two components, the electrical part and the magnetic part. So now, because the atom is aligned north to south, when you introduce an RF signal, it disturbs the alignment.
Sorry, Kennedy, you've muted yourself again.
Okay, sorry about that. Okay, so when the atom is aligned north to south, you have introduced an electromagnetic frequency. So this frequency will disturb the alignment. And then you switch off the RF pulse. When you switch off the RF pulse, the molecule or the atom of the hydrogen will go back to the alignment. So when it's going back, it produces an MR signal. So when the signal is produced, now that's when you introduce a coil. So the coil will pick the electromagnetic signal, convert it to an electrical signal. Yeah, so basically we are talking of the interaction of three things. We are talking of the electromagnetic field to align the atom, and then you are introducing an electromagnetic wave from the RF amplifier to disturb the alignment. And then the third part is the coil that receives the electromagnetic wave, or we can call it the radio frequency pulse, which then now you can process to produce an image. So that is the basic production of an MR image.
Kennedy, yeah, just let me know where you want me to be on the slides.
Please go to the next one. Okay, the building blocks. Okay, thank you. So it's important to understand the parts of these building blocks. So we have talked about the magnetic field. We have talked about the RF frequency pulses. You can also call them the electromagnetic pulses. And then now there is the signal processing and image reconstruction. Next slide, please. Okay, I was talking about the main magnetic field. So this one will align the protons in the body. So the protons in the body mainly is the hydrogen. So the hydrogen is the one that's going to produce the signal. We have gradient coils. So the for you to locate a different part of the body. For example, you want to scan the abdomen, you want to scan the liver. So that part is where the gradient coils come in. And then we have the RF coils. So this one will be used to receive now the signal once the protons are excited by the RF amplifier or the radio frequency pulses. And then there is an important part which we are calling the shimming coils. So the shimming coils, they help correct the imperfections in the main field. So the shimming part is whereby you're trying to make the main field homogeneous. So for example, you know, the field is in 3D shape. We have lines. So the shimming will enable the lines to be smooth, or I can say curved in shape instead of being wavy. So we have the shimming coils. So the shimming can be either passive, or you can use actually metal pieces. So that is the ferrous. You can have various shapes of the shimming metals. So that is the iron. Also, we can use the coils, which are just superconductors that will introduce a countering field to the main field. And then now we have computers, which now control the entire MR processing and image reconstruction. The next slide, please. Okay, so MRIs, now they stand out in the field of imaging because you don't subject patients to ionizing radiation, for example, CT scans. And then for MRI, mostly they are used to scan soft tissues, unlike CT scans and basically which are X-rays, which scan bones or dense parts of the human body. And also MRI, their only challenge is the noise that is produced during scanning. Otherwise, you're not subjected to any ionizing radiation.
Yeah, I think that's basically, I think, it on with respect to the basics, unless maybe Kennedy wanted to elaborate maybe something a little bit more.
Okay, thank you. I think the slides are quite informative. I will wait for questions in case there are any after the presentation.
Yeah, thanks a lot, Kennedy. Yeah, so next we'll be looking at the second part of our presentation, which is how to acquire an MRI machine. Secondly, how to prepare your site for an MRI machine. And thirdly, what are the challenges or what are some of the things that you will experience while trying to acquire an MRI machine. So the first thing you need to do when thinking about acquiring an MRI machine is doing a needs assessment. So you basically need to first identify what is your clinical demand, because for us, yes, we are technology people, we are engineering, but we serve as a demand that is non-technical and non-engineering. So doctors, radiographers, radiologists, and other clinicians who want these images then come to us and say, you are the technical people, can you give us a solution that can address this kind of diagnostic demand? So when talking about clinical demand, one of the things you look at for your facility is what's the patient volume. So you need to look at the current patient volume and what the projected growth. An MRI machine is an expensive machine. Superconducting machines, for example, go in the region of $1 million and above, depending where you are, and depending also the taxes and everything in the specific country. But typically, you'll be facing a bill of around $1 million and above. So it's very important to know, do we have the patient capacity to actually sustain an MRI machine, or can we keep maybe referring to a nearer facility? So secondly, while thinking about patient volume, is also thinking about what are the diagnostic gaps that are there with your current imaging portfolio. So you have a CT scan, you have an MRI machine, you have a CT scan, you have an X-ray machine, maybe you have an ultrasound machine, you have all these things. And the question that you ask yourself is, what is not being addressed by this particular equipment that needs to be addressed with an MRI machine. So maybe soft tissue, you're going into brain scans, you're going into neurology, you're going into, you know, advanced musculoskeletal kind of imaging needs. Then you start talking about, you know, can we get an MRI machine? The second bit is an assessment on the kind of technology that you need. Typically for superconducting magnets, we are seeing they come in mainly two areas. One, sorry, yeah, I can see somebody who says to reload the page, but it's I think it's showing clearly. Maybe. Yes, can you hear me?
Yes, I can hear you. You can just continue. Whatever comments are coming in, you address them at the end of the presentation.
Okay.
Just continue with the presentation.
Yeah, no, I think I saw someone saying the page is not moving. So yeah, I think it was important for to address that one in real time. Yeah. So typically superconducting magnets will come in two forms. One is a 1.5 Tesla and 3 Tesla. Now, in advanced research institutions, we are seeing some demand for 7 Tesla, but for most clinical needs will be addressed by a 1.5 Tesla and a 3 Tesla. But a 3 Tesla is much more expensive, probably ×2 or ×3 in terms of pricing above a 1.5T. So if you look at how you classify your level of hospitals, so mainly your level 5, level 4 kind of facilities will do with a 1.5 Tesla. But for advanced university referral hospital, university research centers, referral hospitals, and those kinds will probably also go for an additional 3 Tesla to meet all their scanning needs. Something else that you need to think about is what are the special capabilities that this MRI will be bringing. You know, so you need to think about, will you be doing cardiac? Do you have experts in cardiac who will want cardiac MRI, functional MRI, mainly in research areas? So all those things would really be something you need to think about as you're thinking of the purchasing decision. Then we talked about the current equipment. What is the capacity? Do you have maybe like some facilities, referral facilities and research institutions, mostly you'll find have 2 MRIs, 1.5 Tesla and maybe a 3 Tesla. And for those, maybe the first thing to ask yourself before going for another one is what we have currently, is it able to meet our needs? And what are the limitations maybe for us to move to also add a 3 Tesla to the portfolio of maybe 1.5 Tesla that we have? So is it an age issue, or is it the condition of the existing equipment is no longer serviceable? So those are the things you think about as you're doing that. Then most critical also would be, the capital investment required and the return on investment. So a lot of these decisions, if you're coming from a private sector setting, private hospitals, they look at the capital outlay required versus the return that the MRI will bring. If you're in a public facility, the major decision will be what kind of clinical needs do we need, and is it worth the capital investment to do that? So that brings in the issue of cost. Two, what are your funding sources? Is your funding maybe the government through the Ministry of Health? Or is your funding private grants if in the event of a private hospital, or is it internally sourced funds also for in the case of private hospitals mostly, and all that? So thinking of what are the funding options is really important. Then as you're thinking of the funding options, you've done the capital outlay, there will also be the operational expenditure. So you will need to service the machine, you will need to maybe hire a radiographer, you will need to pay salaries in the MRI suite, you'll need people to clean the area, you will need all these things. What are the operational costs, and will you be able to sustain those operational costs? So it's in our facilities, maybe government facilities, maybe some return on investment is not a big driver of the decision making, but the capital investment is. Yeah. So moving on to, I've talked about operational costs. Maybe something I didn't add there was the cost of electricity, the cost of cooling. But I talked about staffing needs and those kind of needs. Then another decision sometimes you have to make, especially in the private sector, is would you go for an outright purchase or would you go for a lease? And in our scenario, maybe in Africa, we see a lot of outright purchase because the financial markets are not so advanced where you see lease options, but they're coming up. We see a few hospitals coming up with some lease options, but still very limited utilization of the lease option. So in our market, majorly what we see as Philips is outright purchase. Then the other thing you need to think about if you're thinking of acquiring an MRI is the vendor selection. You need to do your market research. Who are the key vendors? Of course, as Philips, we are one of the biggest vendors of MRIs globally, and actually we produce some of the best MRIs that are currently in the market. Our leading technology, for example, where we are talking about helium-free systems where you do not have to top up helium anymore, are market leading. We are #1 in that. So you need to do your research and say, for my area, maybe if I'm in a remote area, like maybe I saw someone say they are from Morogoro in Tanzania. Is a town I've been to, but Morogoro is a fairly urban setting. But there could be interior areas where quick access to engineers and service vendors who can repair your machine on time would be a problem. So those are the things you think about. What's the service network of the vendor who's giving you that MRI machine? Number 2 is what are the capabilities of the machine? If it quenches, how much am I paying for the magnet to be restored? So those are the things that you're always thinking about. Then next step you do is a request for proposal. Of course, I think a lot of biomedical engineers on this call, if you're working in a government facility, then this is a common procurement, way of procurement. So request for proposals. Then after you've evaluated the proposals, you can and you've narrowed down to a few vendors, you can say, let's visit some of those vendors and where they have installed machines. So if you're maybe remote in a place like in Kenya, maybe you're from a remote area, you might say, I want to visit another site which is as remote as mine where you've installed such a machine, and hear the feedback from the people and hear also the feedback from the users in that area. So demos and site visits are very important before you make your final decision. Then an MRI machine is not just about the equipment. So a lot of times there are a lot of ancillary assets that come with the MRI machine. So first, you need a considerable room size. Then, since an MRI produces magnetic radiation, then you need to actually do RF shielding to prevent that magnetism from interfering with either other things around the area or electronic communication or things like those. So then the other bit that is very important, and maybe Kennedy might touch on it, is cooling. Cooling is the most critical for your MRI. Remember, Kennedy has mentioned that we are applying superconductivity, where we are reducing the resistance of copper almost to 0. So by reducing the resistance of copper almost to 0, it allows us to generate the kind of magnetism that we do. So that's why we are calling it superconductive. So you're taking your normal conductor, which has resistance, and you're taking away the resistance to ensure it's superconductive. And to do that, you need to cool. So copper, for example, at I think maybe Kennedy, you can help me. How many degrees Kelvin do you get superconductivity at for an MRI?
So for the ones that we have, it's negative 269 degrees Celsius or 4 Kelvin.
Yeah. So to get negative 260 or thereabouts degrees Celsius, you need a cooling mechanism that can cool to that level. So you'll have to deploy chillers. You'll have to, make sure that you have the MRI comes with compressors and all that. But the part of the hospital will be providing the chiller that provides the chilled water that goes to cool in the helium. And the helium is what actually reduces the temperature of the metal to zero conductivity. So to zero resistance, sorry, which is the opposite superconductivity. So cooling is critical, and especially since all of you are engineers here, I think one of the most important things that you need to remember from this conversation, if you don't pick anything else, remember that for an MRI, the most important factor is cooling. Then the rest, from a technical standpoint, to make sure the equipment is always there and the magnetism is not lost, the most important factor is cooling. Then there are weight considerations and installation challenges. If you're typically MRIs in the past have been very heavy. They range from 3 tons, 5 tons, and above. So a lot of these existing buildings, maybe were not designed to carry that kind of weight, especially maybe on first, second, and third floors. On the ground floor, it's in contact with the ground, so you can make modifications to support that weight. But on first floors, maybe you need major structural changes to support that weight. But the good news is companies like Philips are coming up with helium-free. Where previously some of the biggest factor driving the weight was the amount of liters of helium in the magnet. Now with the new innovations, we only take 7 liters in the magnet, which significantly reduces the weight of the MRI machine. And what that does is now it's allowing us more capabilities to install it on first floor, second floor, third floor, depending on where you are. But you will need your structural engineers to actually come assess your building and say that it's valid to install it on a floor higher than the ground floor. A lot of, probably 99% of our installations are always ground floor. Yeah. Then there are things like safety standards that you need to think about. Like I told you, these are very powerful magnets. They are 30,000 times the pull of gravity. So you can imagine gravity and then 30,000 times. So what that does is it makes it very important to actually shield the magnet and to adhere to magnet safety. So you have to have protocols for maybe putting patients into the MRI suite. How do you make sure that you scan them not to be carrying any metals? There are cases where people went into the MRI suite with guns. The gun was pulled from the holster into the MRI, and an accident can happen where it actually triggers itself. We've had a few, but some cases where we've had globally of oxygen tanks, nurses walking with oxygen tanks into the MRI suite to the patient, and that causing damage to the MRI because the whole oxygen tank is a ferrous thing. It's pulled into the magnet. So safety is critical for MRIs, and you need to, as you're thinking of procurement, these are the things you need to think about. Then one of the other things that we do, I'm looking at time here, I think we are still okay, is facility planning. So an MRI suite will typically compose of 3, 4, maybe sometimes 5 rooms. So there's the examination room where the main equipment is installed. Then there's the what do we call it? There's the equipment room, where we have the equipment being installed, the equipment that supports the magnet being installed. Then we have the operator, where the operator sits, and maybe a changing room for the patient and a reception and things like those. So as you're thinking about your MRI, you need to think about all these things in advance. A good thing, most of the vendors will support you in designing your facility to make sure that it accommodates the MRI. So we have planning departments where when you decide to procure, we can come look at your facility, look at your proposals, and then advise on how to structure the room so that they can accommodate the MRI. Yeah, some of the things also that you need to think about as you're thinking about acquiring the MRI is regulatory issues. One, does the vendor comply with FDA regulations, CE regulations, and all that? You know, this is important. We are living in a world where health quality of the healthcare we provide is highly monitored, and we need to make sure that it complies with the law and the set regulations that sometimes have been set with these organizations from countries that have been doing this for a long time. Then accreditation. If your hospital is looking to go into accreditation like JCIA or any other accreditation, then you also need to think about that as you're designing your MRI room. You also need to think about licensing and safety. What does the Food and Drug Authority in your country, in Kenya it's called the Pharmacy and Poisons Board, what does it say about this? What are the safety certifications that are required? But like Kennedy said, the good thing with the MRI, it produces non-ionizing radiation. You won't have those radiation challenges, but you'll have other challenges to do with magnetism. So you need to, think about those. Magnetic radiation and not ionizing radiation. So here you are, you've made your decision. Now, how do you implement the MRI installation and acquisition? So number one is, think about the timeline. So you need to sit down with your vendor, do a project plan, indicating everything, including what happens when, because remember, a vendor won't deliver a magnet to a site that is not ready. An MRI is an equipment that needs constant cooling, like I said. So you need to make sure that your site is fully ready. And when the magnet, which is the final piece that is shipped, comes in, your site needs to have the necessary cooling, needs to have the necessary RF shielding done. So they've built the cage and all the other electricity needs, network needs, and all that are already done. So you need to work hand in hand. Your project manager with the vendor project manager need to work hand in hand to make sure that everything falls in place like a puzzle. And that's why that timeline is important. The Gantt charts showing each activity and when it's being complete. So you can start, but one of the biggest challenges I've seen, for example, with our government facilities, for example, in Kenya, is the planning. Sometimes they plan for budgets that have not been deployed. So you find that you've started building your building, and then all of a sudden maybe government funding is cut, and you have a half-built building, and MRI has not been shipped, and you have maybe to suspend and wait for the next funding cycle. So you need to make sure that you've secured the money and made sure that you've actually ring-fenced that money for that particular need. It's not something that you can start and go halfway and then wait to finish another time. So most important, you are the guys who are advising the decision makers. You need to advise them to ring fence the money. Once you agree this is the budget, ring fence that budget, have it ready so that when the implementation starts, there is no stopping. It goes all the way to the end. Some of the things you also need to think about is training needs and training programs. Specifically, radiographers, you'll need to find out, are they familiar with this equipment? Have they used it before? And if not, what is the ramp up, that is required to bring them to the level required to run the machine? So typically, some of the vendors will assist you with training your staff. if they are not trained, or identifying places that you can send them to be trained. This also includes biomedical engineers. A lot of there are things we can train you actually to do, because sometimes some of these issues are just because of lack of training. You get some issues that develop, and this could have been addressed if the biomed engineer had been trained at the point of installation on what to do, what to check, and how to maintain your equipment to keep it running throughout. Another key, I mean, MRIs produce a lot of data. So one of the things is the computers that are supplied with the MRI machine might not be able to have enough space. So you need to think about what is your RIS, what's your PACS integration strategy, where as the images leave the machine, they are stored. Some countries have regulations where images for 7 years before you do away with them, or before you delete. You can't delete patient images until maybe 7 years after the test. So these are some of the things you need to keep thinking about as you develop your procurement plan and the network infrastructure associated with that. But key, especially from a technical standpoint and maintenance standpoint, is thinking about how can you make sure that there is internet always available? Because with the modern machines, we provide remote monitoring, maintenance strategies where we can actually log into the system, tell you what is the challenge or what is about to fail, and look through the system and give you some information that you might need with respect to that. So it's very important that you put in the necessary internet infrastructure to make sure the machine can also be reached remotely by the vendor. Yeah, this is a visual. Yeah, I think you know the Gantt charts and for project management. So this is just a visual of that. Then finally is mostly on performance and monitoring. One, what are the quality assurance tests, which maybe Kennedy will tell you about. There are phantoms that are delivered with the scanner, which allow you to do some quality tests, image quality tests, maybe on a day-to-day basis or on a weekly basis, which ensure that the images you produce are in line with what was expected and what the machine was designed for. So those are some of the things that we look at. Then there's usage tracking. If you're in administration or you are in management, then one of the things you like to see is how is the MRI being utilized? Are we doing enough patients? Do we have any bottlenecks? Is there a reason maybe why we send maybe some patients home and ask them to come the next day, so that we can address those bottlenecks? So some of those things can be tracked, and you can monitor those as after installation. Yeah, so and also with performance mentoring, monitoring, you need to think about the maintenance schedule. Most of these equipment would have between 1 to 4 maintenance, preventive maintenance activities in a year. Some might have 2, some might have 4, depending on the type of equipment, the vendor, and the company that actually, and the policy of the company that sold you the machine. A lot of the companies will provide support for preventive maintenance because there is tooling required. There is a lot of things that are required that you might not have as a day-to-day tool or standard tools in a hospital. Yeah, and that's basically it for acquiring an MRI machine. So Kennedy will quickly take you through some of the common maintenance activities and some of the faults that he sees in the field and what you can do about them.
All right, thank you very much, Boniface, for that. So before Kennedy comes in, I'll just kindly ask you, Boniface, to mute your audio as Kennedy is speaking. Yeah, that would help us a lot. So over to you, Kennedy, with the maintenance activities and faults on the MRI machine.
Okay, thank you for the presentation, Boniface. You have reinforced the knowledge that I had before of the various things that we should be considering apart from the technical part of the MRI. So the console area, this is the area that the user sits while scanning. So for Philips, we have the monitor, we have the computers. Some of the common faults that we usually get from customers, if you can remember what Boniface mentioned, the MR images produce a lot of data. It can go, a single scan can go up to around 1 gigabytes or around 300 megabytes. So they can be busy some of the times until they forget to clear the images. This can bring a problem to the computer. So the major problems we have is storage, the memory getting full, and sometimes users, they force for example, the machine hangs. If the user goes to the technical room and switches it off, it can easily corrupt the software of the computer. Next slide, please. So the cooling cabinet is very key for the MRI. It's important to follow to the letter the service bulletin or the technical information that's provided by the vendor. Some of them, if you interact with different MRIs from different vendors, most of them use water. So the quality of the water that's being used is key. It's advisable to use deionized water, for example, water from the reverse osmosis plant, or you can also purchase from factories or companies that produce deionized water. So the cooling cabinet, some of the components are cooled by air, and most of them are cooled by water. So you just ensure, if it's cooled by air, you ensure that there is a free flow of air. The filters are clean or they are changed on time. The area where the equipment is installed, the air is good. There are no dusts or the doors are not opened. The AC is working optimally. Then you'll not have a lot of problems in the cooling area. So basically, we are talking about some of the components can be air cooled or water cooled. And then you just check the quality of the air and the quality of the water, and also the flow of the water and the pressure. For us, we monitor the flow and the temperature. I think also the pressure is key. So the pressure of the flowing water, the rate at which the water is flowing, it can be in liters per minute or liters per hour mostly, but some can use terms like gallons per minute or gallons per liter. They're all the same. So you ensure the flow is okay and the pressure is okay. Next slide, please. Okay, so this is also very key. Fortunately, we are moving into the helium-free era. I'm also happy that technology is making work easier for everyone. So for, I can say, the current MRIs, they use a lot of helium, around 1,500 liters of helium inside the magnet. And the helium is at negative 269 degrees Celsius. Naturally, the helium changes state. It boils. So it changes state from the liquid form to the gaseous form. So for you to maintain the helium in liquid state, you need, there's something called a cold head. So the cold head operates at this temperature. So it will cool the gaseous or the helium gas back to helium liquid. So the refrigeration system has the cold head, and then the cold head is powered by something called a helium compressor. Is almost the same as that one that we have for refrigeration at home. It's a compressor. The important things to check are the pressure of the compressor, and then another thing is to check the cooling of the compressor. So the compressor can be water cooled or air cooled. For air cooled, like I mentioned before, ensure there is a proper environmental condition. That is, if the ACs are working, the quality of the air in the technical room, that the doors are not open or the windows to allow dirty air to get in. And for the compressors that are water cooled, you ensure that the chiller is working optimally. You'll realize that most of the sites, the chiller is outside the technical room. So the chiller can operate in the outdoor setup for most of the installations, especially in Africa. So the compressor is cooled by the chiller. So you just ensure the chiller is operating within the parameters that are set by the vendor. So for us, we check the quality of the water in the chiller. So we have deionized water or water from the RO plant, the flow of the chiller, the rate of the coolant that's flowing, and also the pressure. So once you monitor this thing on a regular basis, if possible, you can do it on daily basis, and then you learn the trend. Then you're able to see, this is how my equipment operates. Then you're able to monitor if there is something unusual. So you can do in the morning, lunchtime, and evening, especially during, or if it's your first time or during the initial installation. So the cold head also has a scheduled maintenance period, as we usually replace every 4 years. And then you can replace it based on performance based, or for example, you can say 4 years, or based whether the cold head will fail before the 4 years. But for us, we follow strictly the period when the cold head is supposed to be replaced. Also, we just monitor the sound from the cold head. Normally, it has a smooth sound, or if you monitor it regularly, for example, daily, you can be able to learn the sound produced when the cold head is running. So you'll be able to know if there is something unusual. Next page, please. Okay, so the magnet has the liquid helium inside. So if you have your cold head running okay, your chiller is running okay, you're barely going to have any issues with the magnet. So some of the activities or the maintenance activities we do on the magnet, you can open the magnet and then you inspect for ice buildup inside. So this one can be done when the cold head is being replaced. So once you have all this working okay, then you'll not have any issue with the magnet. Another thing with the magnet, if the cold head is running optimally, there would be no need to refill the helium. If it's not so, then you can refill during the period that you are changing the cold head. Next page, please. Okay, then I think we go straight to question Q&A section. Then Janet will guide us on how to answer the questions. Thank you.
All right. Thank you very much, Boniface and Kennedy, for that wonderful presentation. I know the audience are learning a lot of things. And just a reminder, very soon we'll be pasting the link for the form for everyone to fill, so that we might be able to identify you when it comes to issuing of the certificates for those who are going to attend 60% of the webinars. So now we're going to the questions. I can see the form has been tested. All right, so I'll first read 2 questions, and Boniface and Kennedy, you help us in taking those questions, then I'll give it a chance to one person who has raised their hand. So the first question is saying, this question is actually coming from Laz. He's asking, with the new helium-3 that is in the timelines before the next image, with the new helium-3, what is the timelines before the next image is taken? I know there is a difference in the selection of parts to be exposed. In short, what is the throughput of the machine? That's the first question. And the other question, which was coming from Simon, he was asking about the leasing process. Are there options for leasing the MRI machine? And if yes, what is the process involved? So you may help us in taking those 2 questions. The first one is asking about the process of leasing the MRI machine. And the second one is asking about the timelines before you take the next imaging, as well as the throughput of the machine. Thank you.
Yes, so I think, Kennedy, maybe you can take the one on the helium-free, and I can take the one on the leasing.
Okay, thank you. So I've understood the question that they're asking for the throughput of the new helium-free, and also how long before you do the time between exams. I think that's how I have understood the question. So the throughput, the helium-free is mostly saving on the helium, because I've mentioned the other MRIs use 1500 liters. This one uses less than 15 liters. So you're comparing 15 liters versus 1500 liters. So it's more of saving. It's just a technology improvement. In terms of throughput, the part that's improved, especially on our system, is the software part. So the software is improved to make the system work efficiently, considering also that you have had improvement on the saving in terms of helium. And the timeline, also I think Boniface can mention something about the new system in terms of throughput. And then the timeline between exams. So it depends with the patient and also the examination. For example, if you're doing head only, it can be around 15 minutes. For example, you want to do head, neck, and the whole spine. So the head will take 10 minutes, the spine will take around another 30 minutes. So this one will affect the timeline. So when you're changing patients, this one depends also on the speed of the users. So the machine will not develop any problem if you end one scan and start another scan.
Yeah. So just to highlight, I think the innovation around the helium-free doesn't affect anything else beyond the cryogenic, which is the refrigeration element of the MRI. So if you have a helium-free system and you have a system that is zero boil-off, and you have the old systems that had a little bit of boil-off, there is no difference in terms of the speed. Actually, because of the innovations in software, you might find that the newer systems in terms of software, in terms of the computer hardware, they are probably a little bit even faster than the older. So really the speed here is dependent on the test you want to do, and two, how your radiographers would maybe switching between the patients and all that. In addition to that, actually, as Philips, we have also one of the best innovations, which is a software called CompressSense. So what CompressSense does is it actually makes your tests faster. So I see some of the people, for example, I see somebody who's raised his hand here, Engineer Harun. They have CompressSense within their facility. The users can tell you that with CompressSense, they actually are able to maybe a test that could take 1 hour. They're able to reduce it to 30 or 45 minutes, depending on how the user wants. So with the new helium-free system, nothing has changed in terms of how you do your patients. What has changed is the internal, is the technology, is the back-end side. The cryogenic cooling is what has changed. Like Kennedy told you, we've moved from 1,600 liters to 7 liters of helium, which is one of the green elements also that Philips is trying to bring in, because helium is a scarce element. So in the issues of sustainability, going green, we are innovating in that direction. So no difference at all. I think that's the worry, that with this, there's a trade-off to make on the patient throughput. There's no trade-off to make with respect to that. Then there's the question of, I think, Simon, I see, one of our leadership in AMEC in Kenya. I see you are there. And I see one of your questions, but yeah, I think the lead glass, I think for this, we are really looking mostly about the shielding, because there is no ionizing radiation. So what we are looking at is RF shielding, how much of the magnetism will get to the operator side. So I think maybe Kennedy, you can take this one also. I think the glass that is delivered with the MRI, it has some tiny copper threads to reduce the shielding, but maybe Kennedy might be able to elaborate that more.
Boniface, that's correct. Yeah, so yeah, basically it's just to prevent electromagnetic waves from going in or out. So basically what copper does is to ground the signals.
Yeah. Great. Thanks. Then I see another question that I think, Janet, you talked about. I think it's also from Simon. I see it's more to do with the leasing option. Now, leasing is basically a financial innovation. So as a company, we don't do the leasing, but we partner with companies that do leasing. So basically, when you do leasing, that company will purchase the MRI from us. we will install it at your hospital. We'll be the one to install it. We'll be the one to, we are the front, we are the ones at the forefront of doing everything, but we'll bring in a financial company to lend you the money, or to lend to buy the machine on your behalf, and then you will be paying them using a leasing model over the period maybe that you agree. So the thing that happens with this is mostly you agree on what the payments are, the monthly payments and all that, and they will have a separate contract, which is a leasing financial contract. So no difference really with the purchasing. The only difference is you don't get to pay the money upfront. Another company will buy that MRI on your behalf, and then you'll be servicing it like a loan, or maybe you have an agreement where once the lease is over, either you keep the machine or they take it away, and then that maybe can reduce your leasing bill. Yeah, I see there are a lot of questions on the comments. Yeah, I hope we'll get through all of them.
All right, thank you very much. We may not be able maybe to answer all the questions in the chat, but then at this point, I would like to take 2 hands, and then we close because of the time. So Engineer Harun, you start, and then Good Luck, you come next. You can unmute yourself and raise your question or your comment.
Excuse, can I talk?
Yes, go ahead, Harun, and then Good Luck.
Okay, thank you, Janet. Thank you, team. Thank you, Boniface and Kennedy. Actually, as I've actually indicated, been able to test your technology, your involvement, and your machines. And thank you very, very much. I would like to actually preferably put out this issue of, this machine, number one, is, very expensive technology, much is required. One of the things I would wish to urge and advise any other person, maybe in the intention to acquire a system is, and preferably this you will answer, how do you assure an uptime guarantee, when one is purchasing or going for an MRI? Because one of the things is sometimes, one go for a system, it takes so long to do the installation and completeness. What is your uptime guarantee, during the acquisition period?
Yeah, thanks. So I've noted that question, uptime guarantee. Maybe we can take the next one, and then I can answer both of them at the same time. Good Luck, Engineer Good Luck, I see you.
Okay, yes, thank you very much for the training. My comment goes like this. Actually, I work in the teaching hospital, we don't have
Good Luck, can you please be close to your mouthpiece? We cannot hear you clearly. You're far from your...
I said we don't currently have an MRI machine in my facility.
Sorry, Good Luck, I'll cut you short. May you please type your comment or your question in the chat, because we cannot hear you clearly. You're a little bit far from your mouthpiece. Okay, as Good Luck is typing, Boniface, can you answer the question that Engineer Aaron asked, so that we can close this?
Engineer Aaron, I think, has brought a very good point. This is the concern with respect to uptime. So uptime is really important, and one of the things we do as vendors, because it's not just about the purchase of the machine. Most MRIs will last you between 7 to 20 years, depending on how you want to use them and how you maintain them. So one of the things that we bring forth is the element of risk management on behalf of the hospital. So because this is a highly risky machine, anything goes wrong with the cooling, you have to spend, if in the event of a quench, you have to spend anything from 300,000 USD to 500,000 USD just to bring it back to where it was. So for that reason, and for those risks, as Philips, we take over those risks from you with respect to a contract. And on that contract, we guarantee you a certain level of uptime. Now, each contract is different, but depending on what you want and depending on your needs. So we customize the contract depending on your needs. But typically, what we are offering most of the time is 90% or 95%, depending on one, what your needs, two, what you're able to pay for, three, all your requirements around. Do you want to work on weekends? Do you not want to, maybe you only want to work on weekdays? So we give you all these options, vehicles, and the pricing options are different for each, and we give you an uptime guarantee based on that. But what I'd like to say is for our systems that we've installed across East Africa, I think one of the things that we've managed to get is above 95% uptime. Even for the customers who have signed a 90%, we've managed to get above 95% for most of them. And the way it works is because we are the experts in the system, we have the technology, we have the knowledge, we train our engineers on a frequent basis, and we have the tools for monitoring. We are able to, for example, know what are some of the things that might break down, and check them in advance. And in the event that they break down, what our uptime guarantee gives you is it allows you're not going to give us a purchase order, you're not going to start procurement process of parts. We immediately start shipping the parts so that we get them to your hospital to make sure that it is running. So it comes in different flavors, but typically we will give you over 90 to 95%.
All right, thank you very much. I've seen, good luck, you have now tested your comment or question in the chat. All right, so I'll answer this for you. This is for those people who have attended the webinars on medical imaging, like you said. I understand your point is coming in that you appreciate if it was a live demonstration, a live session on the MRI, because some people have never had the experience with the MRI, and that's understandable. However, I would like to say if you have more questions of quality, we'll get back to you on that. For those people who have technical questions, we'll compile all the questions and we'll send them to Boniface as well as Kennedy to answer them. And once those questions are answered, we'll relay it back to you so that you can be able to see the answers based on what you've asked. Because of the time, we may not be able to gather everyone and attend to every question that you guys can have. And also, I've seen that Kennedy has answered to say he can make a video call in one of the days on the sites with good luck on that. I hope that also answers your question. And to those people who have been asking for the information that we've been sharing currently, we do upload a recorded video of this session on YouTube. So you will have an access to this video on YouTube if you go to Oxygen Alliance YouTube page. So that one will also help us a lot. And in case you have more questions, you can also contact us at info@oxygenalliance.org so that we'll also get back to you. And very importantly, we are still in the medical imaging equipment series. So we'll be also having another session on the 10th of October. So I would like you to be on the lookout. You can currently mark your calendar so that as we're coming to that, as we're approaching that day, you also be ready for the next session. Just a reminder, we have sent the form. There's a link in the chat for the form for everyone who has attended this session so that you can be able to fill as well as be identified as you issue the certificates. Thank you very much to Boniface and Kennedy for this wonderful session that you've given us. We appreciate, we don't take it for granted. And we know that our engineers and technicians out there that have learned a lot and they would love to know more. So as we'll be getting back to you with the comments as well as the questions, we expect you to also be on our site to answer those questions. But all in all, thank you, our audience. Thank you, everyone. And we hope to interact more in the coming sessions. Have a good evening.